Hey everyone, welcome back to my channel. In this video, we're going to help our robot harvest all the carrots, represented by beepers, from a garden arranged in a diamond shape with 3 layers. We'll approach this problem using computational thinking by breaking it down into simple steps. Let's dive into solving this step by step. Alright, let's get started with the first step of our computational thinking approach, problem analysis. Here's what we know about our harvest all the carrots problem. The robot world is a fixed 12 avenue by 12 street grid, and the robot starts at Avenue 1, Street 1 facing east. Beepers, representing carrots, are placed in a diamond shape across 3 layers. The outer diamond has 5 beepers on each side, totaling 20 beepers. The middle diamond has 3 beepers on each side, with 12 beepers in total. Finally, the inner diamond has 1 beeper on each side, for a total of 4 beepers. There are no beepers on Avenue 12 or Street 1. The robot's task is to move to the bottommost point of the outer layer at Avenue 6, Street 2, pick up all the beepers in the outer layer, then move 2 steps north to the middle layer, pick up those beepers, and finally move 2 steps north again to the inner layer, where it will pick up the last beepers and finish at Avenue 6, Street 6, facing north. By following this diamond pattern, the robot will efficiently harvest all the carrots in the garden, moving layer by layer and collecting beepers in sequence. With these requirements clear, we're now ready to move into the decomposition phase, where we'll break down the problem into specific steps and functions. To solve the task of harvesting all the beepers arranged in diamond shapes, we can break the problem into 2 general steps. First, move to the bottommost point, and second, pick up all the beepers. The first step involves getting the robot to the correct starting position at the bottommost point. To do this, the robot needs to move forward 5 times in the east direction, then turn left to face north, and move forward 2 more times. In the second step, the robot will need to pick up beepers from each of the 3 layers, starting with the outermost layer and working inward. The process of picking all the beepers can be refined into a more streamlined approach by focusing on a repeated sequence of actions for each layer. Instead of handling each layer separately, we can adopt a repetitive structure that works uniformly across all layers. The refined algorithm involves repeating 2 key steps 3 times. First, the robot picks up all the beepers in the current layer, systematically moving along the 4 sides of the diamond shape to ensure no beeper is left behind. Then, if the current layer is not the innermost one, the robot transitions to the next layer by moving forward. This repetition ensures the robot efficiently collects all beepers layer by layer, making the algorithm concise, adaptable, and clear. How do we pick up all the beepers in the current layer? To do this, the robot needs to handle each of the 4 sides of the diamond shape individually. For each side, the robot will first pick up all the beepers along that side. Once the beepers on that side are collected, the robot prepares to move to the next side. This preparation involves turning to face the next side and positioning itself at the starting point of that side. The robot will repeat this process for each of the 4 sides, picking up all the beepers on the current side, and then turning and positioning itself for the next side, until all beepers in the current layer have been collected. By following this method, the robot efficiently clears each layer before moving to the next one. To pick all beepers in the current side or to know if the robot has reached the innermost layer, we need to calculate the total number of beepers per a single side for each layer. The diamond in the outer layer has 5 beepers per side, the middle layer has 3 beepers per side, and the inner layer has 1 beeper per side. From this pattern, we can derive the formula 5 minus 2 times I, where I represents the current layer. For the outer layer I equals 0, the formula gives 5 beepers per side. For the middle layer I equals 1, it gives 3 beepers per side, and for the inner layer I equals 2, it gives 1 beeper per side. This formula helps us determine how many beepers are in each layer and guides the robot in its movement and collection. How to pick up all beepers in the current side? To pick the beepers in the current side, we need to follow a structured process for the total number of beepers per side. First, for each beeper, the robot picks it up. Then, the robot moves up a stair. This means advancing by 1 step in the direction it's facing. Then, the robot prepares for the next stair by adjusting its position to pick up the next beeper in line. This process is repeated for each beeper along the side of the diamond, ensuring that all beepers in the current side are collected before moving on to the next side. How do we go up a stair? To go up a stair, the robot follows a simple sequence of steps. First, it moves forward by one space in the direction it's facing. Then, the robot turns right to orient itself correctly. Finally, it moves forward again to reach the next level or position in the layer. This sequence ensures that the robot moves up one step at a time, making it possible to reach all the beepers in the current side of the diamond shape. How do we prepare for the next stair? After the robot has moved up a stair, it needs to get ready to climb the next one. To do this, the robot simply turns left. This left turn reorients the robot to face the correct direction for continuing its task of picking up the next beeper. By repeating this process, the robot can systematically move from one beeper to the next, ensuring no beeper is missed. How does the robot move to the next layer if it's not the innermost one? To determine this, the robot checks the number of beepers per side. If the number is different from 1, which indicates it's not in the innermost layer, the robot proceeds to the next layer by moving forward 2 times. This move ensures that the robot transitions smoothly from one layer to the next, positioning itself at the bottommost point of the new layer. By doing so, the robot can continue its task of picking up beepers in the outer and middle layers before finally reaching the innermost layer, where it picks up the last set of beepers and finish the task. Now that we've designed our algorithm, it's time to implement it and bring our robot to action. The code begins by importing the necessary sys1 robots library, which provides the functionality to control a robot in a simulated world. After importing the library, the load_world function is called to load the harvest to robot world from worlds folder where the robot will carry out its task of harvesting beepers. The robot is then created with the statement hubo equals robot, and a few settings are applied, such as setting the robot's trace color to blue so that its path is clearly visible on the screen. A small pause of 0.05 seconds is added between each action using hubo.set_pause 0.05 to make the robot's movements observable. Next, a helper function called turn_right is defined to make the robot turn right. Since the robot can only turn left, the function achieves this by making the robot turn left 3 times. This function will be useful later in the code to orient the robot in the correct direction. Another function, move_to_bottom_most_point, is defined to move the robot to its starting point at Avenue 6, Street 2. This function makes the robot move 5 steps east and then turns it to face north, where it moves 1 step north to reach the correct position. The pick function is designed to check if the robot is currently standing on a beeper. If the robot detects a beeper, it picks it up using the hubo.pick_beeper method. To make the robot pick beepers and move, a combined function pick_and_move is created. This function first calls pick to pick up a beeper if present, then moves the robot forward, turns it to the right, moves forward again, and finally restores the robot's orientation by turning it left. To handle the task of picking all the beepers in a layer, the function pick_beepers_in_current_layer is defined. This function takes the number of beepers per side of the diamond shape as input. It loops through each of the 4 sides of the diamond, picking up the beepers as the robot moves along the side. After completing one side, the robot turns left to face the next side and repeats the process until all beepers in the current layer are picked. Once all beepers from a layer are picked, the robot needs to move to the next layer, which is accomplished by the function move_to_the_next_layer. This function moves the robot to steps forward to reach the bottommost point of the next layer. In the main part of the program, the robot begins by moving to its starting position using the move_to_bottom_most_point function. The total number of layers to be processed is set to 3, representing the outer, middle, and inner layers of beepers. The robot loops through each layer, picking beepers from the current layer using the pick_beepers_in_current_layer function. The number of beepers per side is calculated using the formula 5 to asterisk layer, where the outer layer has 5 beepers per side, the middle layer has 3, and the inner layer has 1. After finishing each layer, if the robot is not in the innermost layer, it moves to the next layer by calling move _to the next layer. The loop continues until all 3 layers are processed, and the robot has picked all the beepers in the world. With all of this set up, the robot will navigate through the garden, collecting beepers from each layer of the diamond-shaped arrangement. Starting from Avenue 6, Street 2, the robot will carefully move through each layer, picking up beepers as it progresses towards the bottommost points of the outer, middle, and inner layers. By following the defined steps, the robot ensures that it successfully harvests all the beepers while transitioning smoothly from one layer to the next, finishing its task efficiently. Alright, that's a wrap for today. I hope you found this video helpful and got some new insights. If you enjoyed it, don't forget to give it a thumbs up and hit that subscribe button so you won't miss out on future content. And hey, I'd love to hear from you in the comments below. Let me know what topics you'd like to see next or any questions you have. Thanks for watching, and I'll see you in the next video.